anyway.
हमारी क्लास के सर अब्दुल्ला सर.
Yeah, वो outside से हो गया. ठीक है, now we have recording. Okay, so one of S that must be same as that vector space, and all the vectors in S, they should be linearly independent, right? The vectors in S, they should be linearly independent. So if a subset of V satisfying these two conditions, we say that set is a basis for a given vector space. And the number of elements in that set S, which is a basis, that is known as dimension. Okay, right. So let's come to exercise 4.6. Which of the following sets of vectors are basis for R2? You could see we are having order pairs are vectors with two components, so they will be checking, or they will be forming a basis for R2. Okay, so you will check whether they are dependent or they are not dependent, or they are spanning it or not spanning. So we first check this one. Okay, don't write any comments because I can't check comments in 3 different sections. Okay, so when I say any question, then you can ask question. So we check this one, whether it is forming a basis or not for R square. We first take what? We will be taking an arbitrary element from R square. Okay, that's an element from R square. And we write this element as a linear combination of these vectors. That is A into B. This is equal to C1 times the first vector, which is 1, 3, or plus C2 times the next one. One and minus 1. Right? And then if you remember, I told you we will be considering augmented matrix AB, which will be taking the first vector as a first column, second vector as a second column, and the left side AB as a third column, which is the augmented part. And then we convert this into echelon form. So this is row equivalent to, we can go for row 2 minus 3 times row 1. Okay, so what do we have? That is 1, 1, A. 3 minus 3 is 0. Minus 1 minus 3 is minus 4. And B minus 3A. And if you remember, I told you call this one as number 1, equation 1, right? So you see, this number is what? It is non-zero. This is not equal to 0, right? So we are having two constants, C1 and C2. And after converting into echelon form, we are having two equations as well. It means the system has solution, right? Solution exists. And if solution exists, iska matlab, what does it mean? It means span of this set is what? If you call this one as set S, right? So span of S is equal to R squared. Right? So condition number 1 is satisfied. Now we go for the next one. We check linearly independence. For that, if you remember, I told you will do directly by putting A and B both equal to 0 in equation 1. So put A is equal to B equal to 0 in equation 1. What would happen? You see, this equation become what? This matrix become what? We have 1, 1, 0, and 0 minus 4 and then 0, because we are putting a b both are 0. We say in this case in echelon form we are having two rows, there are two equations, and we are having two variables. So it means this system has only trivial solution. We are having unique solution. Unique solution means only trivial solution, and that means someone is texting or anything else is going on. This implies linear independence, and once it is spanning the given space and linear independent, that implies that the set is what? It is a basis. But that's the way to check it. It's very simple, you see. I explained that in detail in class. So I presume you know what I'm doing here. It's very simple. You'll be checking these two conditions. And what about the dimension? You see, this set contains two elements, so dimension will be 2. And you must remember, I told you R square has dimension 2. So its vector space would contain, it must contain 2 elements. Okay? Okay, let me get rid of it to move to the next one. Right, the second one, you see, in this set, we are having 3 vectors, and a subset or a set containing 3 vectors cannot be basis of R2. Do you know the reason? You should know. Dimension of R2 is 2, so its basis must contain what? Its basis must contain 2 elements, but it contains 3 elements, so it cannot be basis for R2. The same thing in part C as well. It cannot be basis because it contains 3 elements and dimension of R2 is 2. Right. This one, you see part D, it has 2 elements, but yeah, it is 2. That's okay. So you can check it whether it's a basis or not. I thought it's 2, 6. It's minus 2, 6. So they are not dependent. Okay. So we can check it in similar way, in similar step as I have done here in the last question. Same thing in question number 2. So you should do question number 2 as well. We are talking about basis for R3. You see, which of the following sets of vectors are basis for R3? In this case, can this be a basis for it? The answer is no, because dimension of R3 contains 3 elements. It must be dimension is of R3 is 3. Sorry, so its basis will contain 3 elements. So this cannot be basis. This cannot be basis. This cannot be basis. This might be basis. You need to check. I'm not saying that it is a basis. You have to check it. Basis of R3 would contain 3 elements, but any set containing 3 elements may or may not be basis. You cannot generalize it, right? And any set containing more than 3 or less than 3 elements cannot be basis for R3. So these 3 cannot be basis because it contains 2 elements, it contains 3 elements, 4 elements, this contains 4 elements, so they cannot be basis. You would simply say this thing: the dimension of R3 is 3, so it cannot contain 4 elements. And you would check this one, part C, whether it is a basis or not. You can check it by doing the same steps. Question number 3, we are talking about R4. Dimension of R4 is 4. So any set containing elements not equal to 4 will not be a basis. Like this one cannot be basis. It contains 3 elements, 1, 2, 3. This one is containing 5 elements, so again it cannot be basis. So B and C cannot be basis. You would check A and D, sorry. You would check this. Okay. Number 4. Which of the following sets of vectors are basis for P2? You must remember, dimension of P2 is 3. So its basis should contain 3 elements. Again, any set containing elements not equal to 3 will not be a basis. You see, This one is containing 3 elements. We're going to check this one. This, no, because it contains 2 elements, cannot be basis. You would check this one as well. You would check this one. And this one containing 3 as well. So you would check this one as well. So I'm checking one of it, whichever you want me to check. So let me do the first one. The idea is same what we have done in class. So you would do what? You would take arbitrary element a t square plus bt plus c, and you would write that as a linear combination of these vectors. So you would write c1 into v1 plus c2 into v2 plus c3 into v3. Then you would put the value of v1, v2, v3. Call this one v1, this one v2, and this one v3. You would put the values here, v1, v2, v3, and then you would take the augmented matrix. I'm taking augmented matrix here, keeping in mind, right? So I would take augmented matrix for it. How would I do that? You should remember the coefficients of t square, t, and constant will be taken along the column. But the first one we are having -1, 1, and 2. So we would write -1, 1, and 2. The second vector will be 2, 2, 3. 2, 2, 3. Third one will be 4, 0, -1. And the right side will be taken as A, B, C. And then we convert this into echelon form. If it has solution, so we say it spans P2, otherwise it doesn't. And then we stop there. So we go for R2 plus R1 and R3 minus 2R1. So what would it be? -1, 2, 4A, 1 plus 1, that is 0. 2 plus 2 is 4. This is 4. This is B plus A or A plus B, doesn't matter whichever you take. Then we have 2 minus, sorry, it is again, it is R3 plus 2 R1. So 2 minus 2 is 0. 3 plus 4, it will be 7. -1 plus 8, it will be 7. And then we have C plus 2A. Okay. Then you can make the second, this one 1. So we divide row number 2 by 4, or maybe row number 3 by 7 as well. Whatever. 1 by 2, 4 are 2. 1 by 7 are 3. We would get -1, 2, 4A, 0, 1, 1, A plus B by 4, 0, 1, 1, and whatever you got here, we don't care. And then row number 3 minus row number 2, the first column, the second column remain the same. The third will be 0, 0, 0, and then something non-zero. You see this one, C plus 2A minus this one. So this is non-zero quantity. So you would see this is 0, this is 0, this is 0, and then the last one is non-zero. It means no solution. If no solution, it means the given set is not spanning R2. It is not spanning. You say this implies span of S is not equal to P2, you don't need to check the next condition. You would simply say, no, it is not a basis. Even though it contains 3 elements, but it is not basis. तो ये ज़रूरी नहीं है कि 3 एलिमेंट्स हैं तो उसमें बेसिस होंगे. For section C, दा ज़रूरी ना देखा. यो सेट के 3 एलिमेंट्स भी नो बखा मखा बेसिस वी. ठीक दे. No P3 चे कम डायमेंशन दे अगर 3 दे नो द P2 पर हर यो बेसिस के बाद लाजमन 3 एलिमेंट्स वी. For that they converse true na they. The converse is not true. Every basis of P2 will contain 3 elements, but every set containing 3 elements may or may not be basis for it. And you would see in this example. So check in similar fashion for part C and part D as well. What's the difference? The difference will be simply this matrix. You see, in this case we have -1, 1, 2. For the third part, you'll be having 1, 0, 1, 3, 2, 1, 6, 6, 3. For part D, you'll be having 3, 2, 1, 1, 1, 1, and then we have 1, 0, 1. And A, B, C, the same thing. And for independence, then at the end, you'll simply put A equal to B equal to C equal to 0 and see if the system has unique solution. So we say linearly independent. If it has many solutions, you would say that's it. Same thing in question 5. We are having P3. P3 dimension is 4. So any set containing 4 elements will be checked whether it is a basis or not, and any set which contains less than or greater than 4 elements, it will not be basis. For example, part D, it contains 3 elements, not basis. Part C contain 1, 2, 3, 4. You need to check whether it's by basis or not. Part B contains 3 elements, not basis. Part A contains 1, 2, 3, and 4. You need to check it whether it is a basis or not. So do it yourself. Right? The same thing for question number 6. Show that the set of matrices form a basis for the vector space M22. Keeping in mind, dimension of M22 is what? That is 2 multiplied by 2 is 4. And this set contains 4 elements, so obviously it is forming basis because it says show that it is a basis. So you would check it, you show it. Now it says in question 7 and 8, determine which of the given subsets forms the basis for R3 and express this vector as a linear combination of the vectors in each subset that is basis. So you do same steps as question number 2, but you have to do the last step, extra step. Whichever is basis, you would express this vector as a linear combination of those vectors. It may or may not be basis. It may or may not be basis. This is not basis because it contains 4 elements. Part B, again, may or may not be basis. You do same thing. The only difference is afterwards, once you convert that, once you check whether it's a basis or not, you would express this vector as a linear combination of those vectors which form basis. And you know how to do that. We have done that quite a few times. So the same thing in question number 9 and 10. It says determine which of the given subsets form basis for P2 and then express this one as a linear combination of those vectors. They will do same thing. Okay, this cannot be basis. You see it contains 2 elements. Same thing for this one. It cannot be basis because it contains 2 elements. You would check these two, part A, and then express that vector as a linear combination of the other one. Okay, question number 11. That's a different question now. It says find the basis for the subspace W of R3 spanned by the following vectors. So what would you do? I hope you remember that. What's going on? Who is someone is texting her? I told you don't send messages because yes, it is recording. लग वक्ती राज़े पता लगी कन. In each section, do you see who is present in it in the class? So can you take attendance yourself over there? Should I take it? Let me take attendance of section C. It's section C. I may not be able to recognize that. This section C. Oh, come on. Okay, this is attendance of sections. You should maybe, I don't know what to do, what to say. It's ITDOP. This is section C. And I go for section B. Section B is some problem. I don't know. Section B is a problem. Section A, B both has a problem. Okay, what you should do, take attendance yourself, right?
Okay, sir.
Yeah, because there is some issue in attendance as well, so forget about it. Right. So how do we do that in question 11? If you remember, I told you if you are given a spanning set and you want to check whether it is a vector space or not, right? So what do? We simply put all these vectors as a columns: 1 2 2, 3 2 1, 11 10 and 7, 7 6 and 4. Obviously it is not forming basis of R3. It says a subspace W of R3. So we will be converting that into echelon form. Okay, so we are having row number 2 minus 2 row 1. Do you remember leading one's story? Row number 3 minus 2 row 1, first non-zero entry. We will be using the same story here: 1 3 11 7. We're getting big number. 2 minus 2 is 0. 2 minus 6 is minus 4. 10 minus 22 is minus 12. And 6 minus 14 is what? Minus 8. Again, 2 minus 2 is 0. 1 minus 6 is minus 5. 7 minus 22 is minus 15. And 4 minus 14 is minus 10. Now we could divide row 1, row 2 and row 3 by accordingly by 5 and minus 4. We can write minus 1 by 4, row number 2, minus 1 by 5, row number 3. So what do we get? First row as it is 1, 3, 11 and 7. And we have 0, 1, 2, 3 and 2. We have 0, 1, 3 and 2. And then by subtracting row number 3, by subtracting row number 3 minus row number 2. That will give you 1, 3, 11, 7, 0, 1, 3, and 2, 0, 0, 0, and 0. Okay, so this is leading 1 and this is leading 1. So the first two vectors v1 and v2 will form a basis. It is not basis for R3, keeping in mind it's basis for, it means the first vector, which is 1, 2, 2, and the second one, that is 3, 2, 1, is basis for, that is a basis for a subspace. It is not basis for R3 because it contains 2 elements, and basis of R3 will contain 3 elements. So it is a basis for subspace of R3. And what is the dimension? The dimension is 2, because the subset contains 2 elements. So dimension of W, that will be 2. Okay. You would do in similar question number 12 as well. Let me get rid of these things. Okay, so question number 12 is same. Find a basis for a subspace W of R4 spanned by the set of vectors. So take these vectors along the columns and then again convert into echelon form and consider those vectors in which we have a columns and non-zero entries of first non-zero entry of each row. Same thing, question number 13, 14, right? So do these things. Similarly, it says that find all values of A for which this is basis for R3. So obviously we'll go for dependence and so on. So do up to question 14 first, then leave this question number 15, 16, 17, 18. And then we go for question 19. We need to find basis for all subspaces of R3 and R4 of the form. See, how do we do this? For this one, you simply replace what? A, replacing B with A plus C. And then we have C. So what would we do? We would write that as A0 plus 0 C and C. So we take A common from here, 1, 1, 0 plus B, that is 0, 0, 0, 1, 1. Right, so S set becomes what? We get these two vectors. One is 1, 1, 0, and the second one is 0, 1, 1. Now you would check whether these vectors are dependent or independent, but you can see there are two vectors, and I told you that two vectors are dependent if they are multiple of each other. So do you see here 1, 1, 0 and 0, 1, 1, they are not multiple of each other. So these vectors are what? These vectors are independent as well. You don't need to check them. You directly say these vectors are not multiple of each other, so they are independent Therefore, this set forms basis and its dimension is 2. Right? I explained this in the class that what would you do. Okay. Similarly, part B, we are saying A, B, C, but A and B are same. So you simply replace that A with B or B with A. So you would write this one as what? This element will become, oh, someone. This element become what? A, and C. And then you split that into two vectors. One is A0, and the next one will be 0, 0, A, 0, 0, C. 0, 0, and C. And then you take A common and C common. 1, 1, and 0, plus taking C common, that is 0, 0, and 1. You see? So one vector is this one, this is V1, this is V2. Again, there are two vectors, but not multiple of each other, so they are linearly independent as well. So the basis in this case will be 1, 1, 0 and 0, 0, 1. Dimension is again 2. And so on. Right? Similarly, in part C, you would write C is equal to 2A plus B. So you write here 2A plus B, and then again you split the vector, you will get two vectors. In 20, we have same A is equal to 0, so we get 0BC. So you would write that as 0B0 plus 0, 0, C. And then you take vectors 0, 1, 0 and 0, 0, 1. In this case, you have A plus C, A minus B, B plus C, minus A plus C. So you would separate this into three parts. You write this in three parts. A, 0, minus A, plus 0, minus B, 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 plus C, 0, C, 0. So we have three vectors, and then you would check those three vectors are dependent or independent. And for that, you will obviously taking that matrix and homogeneous system of equation and so on to do these questions. So question number 21 as well, 22 as well, question 23, 24 as well. Okay. Yeah, that's it. Do up to 24. So, okay, do up to question number 24. Okay, yeah, if you have any question, you can ask.
No, sir.
Okay, so let's move towards homogeneous system of equation. And in this case, obviously, we'll be talking about basis for homogeneous system of equations. Basis for solution of homogeneous system of equations. So if you remember, we have discussed that already. Okay, that is you will be considering that homogeneous system of equations. You solve that homogeneous system of equations, we get arbitrary constants in it, which we call parameters, and then you split that solution depending one vector on R only, the other one is will be depending on S only, and if you have three parameters, so R, S, T, and so on, and that will give you basis then. For example, if you consider this system of equation, okay, so we take this homogeneous system of equation and convert that into echelon form, right, or maybe reduce echelon form, it's up to you. The solution of this system will be, I hope you know how to get solution from here to here. Yeah, you know how to find solution of homogeneous system of equations. So that is a solution. You should know how to do that. So we are having two parameters. You see, there are 5 equations, and we are having 2 0 rows in it. There are 5 columns, and we are having 3 non-zero rows. The difference between them is what? That is the number of free variables, or that is the number of parameters. In this case, we are having two free variables. So one is s, the other one is t. We separate them, we get this one. Now you see these two vectors are independent because they are not multiple of each other. If they were multiple of each other, you would say they are dependent, and then you would do the process of converting this into echelon form and then going for leading ones and stuff like that. Is that right? Example 2 is simple. We'll be doing that in maybe next chapter, so forget about that at this moment. It's an eigenvalue problem, so or eigenvectors. Example 2, 3 both are same, so forget about that. Right, so let's move to exercise 4.7, where matrix A is given. It says find the set of all solutions to Ax equal to 0. Then express each solution as a linear combination of two vectors. Right, forget about the sketching. You would do only these two things. So can you do it? We have done that quite a few times. There was a question in previous exercise as well, in which we found solution of that homogeneous system of equation depending on R and S. Obviously, our team depending on only on R and S or only R. So we just separate them. Okay. And should I do it or no? It's very simple. You see, a solution of this homogeneous system, you will do what? You will consider augmented matrix, that is AB. You can ask me either in class as well if you have any issue. If we go for -2, -1, -2, it is -4. If you see, row number 2 is the multiple. Is it the multiple? Sorry, it's +2. It's not -2. So row number 2 is the multiple of row number 1. Row number 3 is the multiple of row number 1. So when you convert that into echelon form, you take 0, 0, 0 here. So we do what? When you convert that into echelon form, we get 2, -1, -2, and then 0. And the remaining 2 will be 0. This is 0. This is 0. If you take the operation R2 plus 2 R1 and R3 plus 4 R1. So this system is basically equivalent to what? This is equivalent to one equation, that is 2x minus y minus 2z is equal to 0. Now you see we are having one equation after reducing in the echelon form and two variables. So there will be three variables. There will be two free variables. So we may take x equal to r. You can take either one. And z is equal to s. And then putting these two values here, y will become what? Y will become 2r minus 2s. So altogether, we get solution as x is equal to what? X is r. You would write r here. Y is 2r minus 2s. That's a solution for the first part, okay? And then last one is s. And then it says what? Express each solution as a linear combination of these two vectors. So you would write that as what? R 2R 0 plus 0 minus 2s and then s. And then we would write that is taking R common, it is 1 2 0 plus taking s common, that is 0 minus 2 and 1. So you see that's the second part which say express each solution as a linear combination of two vectors. So that's a linear combination of two vectors. These are C1 and C2. So that's the part B. This was part A up to here, finding solution of this system. And then it says that sketch these vectors in a three-dimensional coordinate system to show that the solution space is a plane. So you have to draw these vectors in space, which is not possible for you. Plot them. Same in question number 2 as well. Again, you see row number 2, row number 3 are multiple of row number 1. So again, you'll be having 2 parameter, 2 free variables. In question 3 to question 10, you say find a basis and dimension for a solution space. You would solve this system, and again by expressing that as a linear combination, you would get what? You would get those vectors v1, v2, v3, or x1, x2, x3, whatever, and then you would find basis for it. If you have 2 vectors or 3 vectors, okay, if you have 2 vectors, just look into them. If they are multiple of each other, take one of it, that would be the basis. And if you have 3 vectors and they are, you have to check whether they are dependent or not. And if they are dependent, then you go for the leading ones. So try it from question number 1 to question number 12. In question 11, 12, it says find a basis for the null space. What do you mean by null space of a matrix? Null space of a matrix basically means, I explained that in the class as well. If we have, we are given a system AX is equal to 0, then the basis is called basis for solution space of this system of equation. And that basis is basically the null space for matrix A. Right? AX is equal to B, AX equal to 0 chikalamunga valu, section C, for section C. Chikalamunga AX is equal to C 0 valu, or the this solution valu, or basis malum ko, nagatamunga vai basis for solution space. ठीक दे ओका कलमुंगा मैट्रिक्स ए राकड़ेवी ब्यामुंगा हम दगा सिस्टम मैट्रिक्स ए न पखपला दा सिस्टम जोड़ को और देन बिया बेसिस मालूम को अगा उमगा सेम बेसिस बरादी अगा बेसिस द मैट्रिक्स ए ब नल स्पेस द para basis भी whereas for this system aba solution space द para basis भी मखके बमुंगा बेजू के आइगन स्पेस द para बे दम दा शे राजी खबा आइगन स्पेस द para basis राजी अब मखके खबर भी शे बम दगा भी 11 12 it says that find basis for null space. Again it says consider this system of equation and find basis for the solution space which will be the basis for null space. Numaga sheba ka weche kam ga waqti ko sirf badalta wa sirf khpala wale ax is equal to 0 ba wale ya pa de matrix ke ba sorry it's ax is equal to 0 pa de matrix ke ba last ke yo bal column wale 0 0 0 0 echelon form the convert ke वो भी आगे बेस दाता solution मालूम कई so do that up to समझे तलाड़ यार where were we wow we went to the chapter 5 चरतलाड़ो कम फलाड़ो no so sure any question no it's not there. Oh, I should have done this way. Yeah? If you click this one, you go to that position, right? Okay. That's. Oh, come on. It is jumping. Yeah, here. So we'll do question up to question number 12, right? We'll be doing these things in next exercise, not next exercise, next chapter, when we discuss eigenvalues and eigenvectors. Right? I'm not doing 4.8 at the moment. It's coordinates and isomorphisms because we haven't got enough time. So I'm jumping towards the next topic. We are not doing chapter 5. We may be going for transformation. Chapter 5 is what? I don't know. Yeah. Okay. Let's talk about rank of a matrix. Should we do it or it's enough?
Sir, it's enough, sir, today.
We have to do, we will be doing chapter number 6, right? Which contains, yeah, 6.1, 6.2. We'll be doing 6.1 and 6.2 only. So 2 exercises from chapter 6 and obviously 2 exercises from chapter 7 possibly. Yeah, 7.1 and 7.2. So keeping in mind, we are having 5 exercises. So can we do that next week then? 4.9 is okay. That's very simple. Rank of matrix, very simple. Again, you'll be converting into echelon form and going for leading ones and taking the basis and dimension. So what do you say?
Sir,
Okay, if you couldn't do that, then again you will arrange one more class in next week. Then maybe 1 hour class again. Is that right?
नहीं
If
सर
you
आज
could
कंप्लीट
do.
करा दे सर मैं बोल रहा हूँ अगर आज कंप्लीट हो सकता है आज कंप्लीट करा दे सर
नहीं, मैं कह रहा हूँ अगर मतलब नेक्स्ट वीक क्लास में नहीं हुआ ना, तो एक और क्लास अरेंज कर लेंगे, एक छोटी सी क्लास.
छोटी सी तकरीबन सर
मे बी 1 आवर. आज जिस तरह हुआ है सिंगाना नो शो.
यस सर अरेंज करें श्योर सर अरेंज कर ले सर
ठीक है सर.
It's up to you. If you are saying so, I can go for it as well.
ठीक है, तो अगर क्लास में कंप्लीट नहीं होता तो एक और कर लेंगे.
बिकॉज असल में प्रॉब्लम दा देगा ना, देख दुमरा गरगट मैट्रिसेस भी डालता था, like बोर्ड में सारे क्विकली कॉलेज चलता था, निकल देर मुश्किल भी का ना. ओ
जी बिल्कुल सर औदा से खबर आता लगा लेंथी भी का ना
lengthy was असल के कर्सर यूज कोमो कर्सर ना बिया कीपैड यूज कोमा दगा यूज कोमा दगा निश्ता देगा ना स्क्रीन पेन पे कमी वगैरह
सही
माउस ना ज़्यादा टाइपिंग कोमा दा राइटिंग कोमा.
जी बिल्कुल सर मुश्किल है शीज़ा इंशाल्लाह सर बल क्लास को हम अरेंज
अवल खो कोशिश को किदेश ख़त्म शी ना कि हमने कहा 3 आवर्स काफ़ी लॉन्ग दगा भी. Otherwise we have your class arranged. Asan these some nishta pake. The first one you see definition is saying if we have a matrix A11, A12, A1n, and then we have columns A11, A21, AM1. So if we consider this row, you see this row is a vector, so that's a one vector we have another vector, we have another vector, and so on. And how many components are there? There are n components in it, you see, starting from 1 and going up to n. So if we consider these vectors, you see R1, row number 1 is one vector, R2, row number 2, another vector, right? And there are Rn vectors in this case. Sorry, there are Rm vectors. That's the first row, second row, third row. So this is basically known as row space. What do we call it? Row space. And that row space is basically subspace of what? That is a subspace of Rn. Because every row contains n component. You see, A11, A12 going up to A1n. So row space is basically subset of Rn. And if you consider columns, there will be n columns, and every column has m components. So column space will be what? That will be a subspace of Rm. Because there are m components. In every column, there are m components, and we are having n columns. Right? So now from onward, we'll be finding basis for row space and basis for column space. And dimension of row space and column space, they are always same, and we call it a rank. You might have learned rank is a number of non-zero rows in echelon form of a matrix, but that's a procedure to do it, to find it. The definition of rank is what? It is the dimension of row space or column space. Both are same, right? So dimension of row space and column space, that is known as rank. And how do you find it? As I said, you will be finding basis for it and so on. So you see, it's a find a basis for the subspace V of R5 that is spanned by these vectors, which we have already done it. What would you do? Two type questions, Razi. There are two type of questions in this case. One is what? You will be finding basis for subspace of R5 containing these vectors, spanned by these vectors, but basis may or may not contain these vectors. You may consider other vectors which form basis for a subspace of R5. Right? And the second case is what? If you are considering the same vectors in a subspace, in a basis. So if you are going for different vectors, what do? We put these vectors in row of a matrix. This is the first row, second row, third row, and fourth row. Zan pa di khabara poi kai. Kacharta munga the subspace dase basis wadu which is spanned by these vectors. Ho aga basis ke chikam elements di aga bal savi, ada bal zainavi. Zaruri chi daga vectors vi ke deyam shi or nam ke deshi. No bya pa mong sakau, we will put these vectors along the rows. Then amakh ke munga pa columns ka chawleo. Us munga pa rows kya chaw. And then we convert this into echelon form. And once you convert it into echelon form, you see this one, then the non-zero vectors, the first vector, the first row, the second row, the third row, consider this as a V1, W1, one vector, another vector, another vector. So these three non-zero vector will basically form basis for a subspace of V. These vectors are different from the vectors which we are given. You see, they are different from these vectors V1, V2, V3. Are they different? The same pakar, if we want to have same vectors like these V1, V2, V3, V4. So what do? We put these vectors in columns, which we discussed already a bit earlier. We take V1 a first column, V2 is a second column, v3 is a third column, fourth column, and so on. And then we convert into echelon form, and then we consider the leading ones. The first row non-zero entry per come column ke de. If it is in first column, take v1. If it is in second column, take v2, and accordingly v3 and v4. ठीक है, द शेप खैरता सो कई बाकी वो इंशाल्लाह नेक्स्ट लेक्चर के डिस्कस को. Right, I'm stopping recording, and then thank you very much.